If there's one thing that I ran out of time inside the classroom, it was teaching the ambiguous case when we had two solutions. It's a lot of work, and that's a lot of step-by-step examples of working through the problems to find all the missing measures of not just one triangle, but two triangles. Well, lucky for you, I found my top 3 examples of me going through this concept inside the classroom, and I compiled them all together into this one video just for you. I hope you enjoy.
So right now, ladies and gentlemen, we're given 58 degrees, B equals 12.8, and A equals 11.4. All right, so let's go and draw the triangle like we would any other time. So I could say here's A, which is at 58 degrees. All right, here's C, and we'll call this one B. C we don't know any information for. B we know this is 12.8, and A we know is 11.4. Right? So automatically, ladies and gentlemen, you can see that I have side-side angle. All right? When you have side-side angle, rather than just following your daily tasks that you do every single day, I kind of want your ears to perk up and say, all right, now is a possibility that I have two cases. All right? Because what we need to be able to do is there's a possibility now that I could have multiple triangles. All right? And here's the case, the reason why. This isn't really a great triangle. I could actually even shorten this up, but what I'm trying to show you guys is you could have a triangle that looks like this, right? Couldn't you also just draw the same triangle if you kind of use this as a hinge and it went right there, right? Because we don't know what angle C is, right? So my angle, 11.4, could be here, or probably a little bit, or we could say 11.4 is here. You guys see how that's a possibility? Because we don't know what C is right now. All we know is what these two side lengths are. And yes, I know my triangle isn't written because this side is much longer than this side and it's shorter, but we'll just get through that. But do you guys see how I could have two possibilities? Yes? That's like me hinging, like that's pretending me like I took this as like a hinge on a door and I rotated it down to here. Okay, so it's kind of like the pathway of that side. So you guys can see there's actually two triangles. I could have a triangle with an obtuse C, or I could have a triangle with an acute C, right? So there is a possibility. So it's not as basic as just, hey, give me money, take it back, you know, the stuff that we were talking about before. So there's a possibility of two different triangles. There's also a possibility, what if 11.4 looked like that? And let's say, you know, here's this side length. Is it a possibility that these could not even touch? It is. Let's say if 11.4 is that long, and then we end up finding C, because we don't know what the length of C is. What if C is short? All right, we'll get through that case. Right now, let's just go and take a look at C. I want you guys to understand there's a possibility of either two triangles, one triangle, or no triangles. And this is always going to happen when we look at our side-side angle. So how does that work? Because, Ms. McLogan, what you just told us to do is just find side-side angle and so forth, or define your missing angles. Well, let's take a look at it. So we have a ratio, right? We have A over A, and we have a side length B. So let's create the law of sines. So we have 11.4 over the sine of 58 degrees equals 12.8 over the sine of B. So we do our same thing. We do our cross multiplication. And we could say that sine of B is equal to 12.8 times the sine of 58 degrees all over 11.4. I'm solving for B. So I cross multiplied and then I divided by 11.4. So I can do 12.8 times the sine of 58 and then divided by 11.4. So I could say the sine of B is equal to 0.9522. All right. Now, ladies and gentlemen, does that make sense for that to be an angle? Right. You got to take the inverse sine, correct? Right? So you take the inverse sine of your second answer, and you get 72.21 degrees. So we say B equals sine inverse of 0.9522, and we could say B equals 72.21 degrees. Okay, So here's where it's going to get a little dicey. So let's go back to the unit circle. All right. What I did is I just found the inverse. Right? I apply the inverse. And the important thing for you guys to understand about the inverse is if I'm going to look at, let's say I have a sine value. Let's look at the sine value of 1/2. If I say the sine of b equals 1/2, is there one answer or two answers to that? There's two answers. Because what is sine equal to 1/2 at pi over 6? Yeah, of course it is. And it's also equal over here, right? So if I was going to say sine inverse b of 1/2, we could say b equals pi over 6 and 5 pi over 6, right? Because your sine is positive in the first and second quadrant. So therefore, there's two actual answers. We could say here it's pi over 6, which is your reference angle. Notice these are your reference angles. But this angle right here is 5 pi over 6. Right? So does everybody understand when I'm taking the inverse of my sine, my domain, I'm going to have two values that are in the first and second quadrant. I have my original angle and also using it as a reference angle. So what I want you guys to understand is if I'm going to look at 72 degrees, where'd my marker top go? So if I'm looking at 72 degrees and I say, if I say the inverse of 0.9522 is giving me 72 degrees, which is right here, do you think I'm going to have another angle that's going to have that exact same sine value? Yeah, I'm going to have the one over here. Right? So what would that angle be? How could you, we know this angle is 72.21. How can I figure out what that angle is?
90 minus 72.
Close. Not exactly 90, but if we take 180 minus that, we'll get what this we'll get the remaining angle. Okay? So let's go and take so let's go and take 180 minus our angle 72.21. And what that gives us is B is could also equal 107.79.
Wait,
It's okay, we're not done yet. Yes?
if we're doing it that way, what about the incomplete?
What do you mean?
Like the last green line on
This one?
What about the rest of the space after?
Here?
Yeah.
No, this from here to here is 72.21 degrees.
Oh, okay.
So we want to find what that angle is. So we're taking 180, minusing this, and that's going to give us that angle. I'm not done explaining. I'm still going to kind of go through it. Do you kind of understand, though, how there's two different angles that have the same sine value? Okay. Do you understand here how these both have the same sine value? 1/2 and 1/2, right? So same thing with this. If I give you one angle, you know there's an opposite one that has the same sine value, right? These two angles are going to, I don't know what their coordinates are, but they're going to have the same sine value, right? So if you find one, you got to make sure you check with the other one because there's going to be two in the first and second quadrant. Okay? So you got to check two angles. We're going to go through now, do both of these angles work? So that's what we do is we create case 1 and case 2. So right now we have B equals 107 degrees. So we could say B equals 107.79 degrees. Or we also said that B could equal 72.21 degrees. So there's a possibility now of there being two different C values. And let's go and see if these work. Okay, so what we do is we write case 1, case 2. So case 1 says that, let's do this as case 1, and this will be case 2. So case 1 says this is 72.21 degrees. That's an acute angle, right? So we could say that's going to look something like this. 58 degrees. That's going to be something like this. So this would be 72.21. And there you go. And this is, oh, wait. Did I get them to be the same? Oh, I wrote it in there, didn't I? Okay. Yeah, we said that could be 72.21. Or we could look at case 2, which says it's going to, I wrote in case number 1. We don't know, that's one example, right?
My question is the case 1, why is
We don't actually know what this angle is right now. I wrote in what B was, and I wrote in what A. Okay, we don't know what C is though, right? Now, Mackenzie, let's go and take a look at this one. So if I say now B is equal to 102 degrees. So I still have 58 degrees. What you guys need to understand is, do you understand when I was taking, well, first of all, we have side-side angle. Do you know in the other ones, I wasn't using the inverse sign, right? When you complete the inverse sign, that's what's giving you your two options, right? Because when you complete the inverse sign, you know that you have to be able to find both values. That's why I drew up the unit circle. When you apply the inverse sign, you have to understand that there's going to be two possibilities in that first and second quadrant. Right? That's why we come up with this case. So,
number 5 then?
what did I find? A, B. So we said B could equal 107 degrees. All right. So now what I want to do is I want to see, do either of these both work? I know. It's not work. So let's go and take a look at case 1. Does case 1, does this work? If I'm given A and B, can I figure out what C is? So 180 minus 58 degrees, right? We're given 58 degrees from the beginning. And then minus our new angle 72.21. Is that going to give us our new value equal to C? So what will now angle C equal? Right? Because on my case 1, I figured out what B was. Now I can figure out what C was. So we do 180 minus 58 minus 72.21. And that gives me, hey, C is going to be 49.79 degrees. Okay?
The value is 72.21, not 72.27.
Oh, it's just 70.21? Okay, let me go and change it then. 180 minus 58 minus, oh, I did it right. I don't know why I wrote that in there. All right, so now that's for case 1. What about if case 2? What if we said now, hey, this is going to be 107 degrees, this is 58 degrees. Is it still possible to create this second triangle? So what I do for this C is I do 180 minus 58 degrees minus 107.79 degrees equals C. So we do 180 minus 58 minus 107.79. And guess what? I get 14.21. So I could say 14.21 degrees equals C. And I know my triangle's kind of looking a little crazy, guys, but it'd probably just be something like that. All right? So we could say this angle is 14.21. So do you guys see how I can create kind of two different triangles? Here's where it's obtuse. Here's where it's acute. But there's two possibilities, and I can still create the same. So we know A is 11.4. B is 12.8. So the last remaining value is we need to figure out what our C is. So we're going to use a law of sines for each value to find our value C. So for this one, I don't know, I'll use A. So I'll do 11.4 over the sine of 58 equals C over the sine of 49.79. That's for case 1. For case 2, I'll do the same thing, 11.4 over the sine of 58 degrees equals C over the sine of 14.21. All right, and then I'll cross multiply and divide. I'm just going to kind of do this to speed this along. So my last one, for case 1, I'll do 11.4 times the sine of 49.79 and then I'll divide that by the sine of 58, and I get C equals 10.26. For this case, I'm going to do 11.4 times the sine of 14.21, and then divide that by the sine of 58 degrees. And here I get C is going to equal 3.29. Okay? So ladies and gentlemen, the main important thing you guys need to take from this, all right? I know it's a lot of extra work you're looking at. You just need to take from this, when you're given side-side angle and you have to apply the inverse sine, there's two opportunities. You could have an obtuse or you could have an acute triangle. You need to make sure you look into both of them. Next, what we're going to do is look into what if there's no triangle at all. All right? And that'll be pretty simple that you guys will be able to see. Okay? So in this problem, what I have is A equals 60 degrees, A equals 9, and C equals 10. So what I'll do is I'll just create a triangle here, kind of see what it looks like. 60 degrees, A equals 9. We'll say here's B, here's C. So C is going to be 10. All right? Now, so what we first want to do with this problem is obviously go ahead and take a look at use our law of sines to be able to figure out what the angle of C is going to be. So I have 9 over the sine of 60 equals 10 over the sine of C. So everybody can get to this point, right, Elizabeth? Yes. Okay, it's pretty basic, and then we can solve for the sine of C. So we could say the sine of C equals 10 times the sine of 60 divided by 9. Okay. What formula?
Yeah, how do they make up these formulas?
A equals sine over A.
We'll go through on this part of the thing.
I know, right? Like, how do they figure out that, like, E equals MC squared? You know?
So now you're just going to take the sine of 60, times it by 10, divide it by 9. And what you have, and then you take the inverse sine of that value. Sorry. So you have sine of C equals, let me do this again for you, 60 sine times 10 divided by 9. You're going to get C equals 0.962250. Okay? Now, to find what C is, you do C equals sine inverse of 0.962250. Does everybody understand that to find the angles? You have to apply them.
And that's going to work right.
Yeah, that's what you were supposed to do even on your homework last night. Now I do the inverse of that, and I say C equals 74.21. Okay? So now I have C equals 74.21 degrees. But ladies and gentlemen, this is getting a little bit more difficult than just doing this one problem. So what you're going to look at is, all right, it could be 74.21. But what I want you guys to understand is, let's go back to our unit circle. And let's look at two angles. Let's look at pi over 6, and let's look at 5 pi over 6. All right? Now, notice the reference angle. These are both pi over 6 off of the x-axis, right? Right? Now let's take a look at our coordinate points. This is square root of 3 over 2, comma, 1/2. This is negative square root of 3 over 2, comma, 1/2. What do you guys notice? Do you notice that for each of these angles, pi over 6 and 5 pi over 6, the sign is exactly the same, correct? Right? Sign is exactly the same. So when you're finding the inverse if you're finding the inverse of a value, you could possibly, for sine, you have two positive answers. So there might be two positive solutions. So let's go and take a look then of what would be, if this is 74 degrees, what could be a possible other solution? So to find that, I could say C equals 180 minus 74.21. Again, what I'm doing is I'm taking 180, subtracting my angle to be able to find the other possible angle. We're going to get to that in just a second. So I add 180. So we take 180. And that's going to equal 105.79. So what I'm trying to tell you guys, if you look at, take this for example. If you guys take the sine of 74.21, okay, so 74.21 sine is 0.9622. Then
Attention
take the
teachers.
sine.
All remaining juniors who have not been screened for vision screening may go to the media center at this time. Again, all remaining juniors who have not been screened for vision screening may go to the media center at this time. Thank you.
Okay. So what I'm trying to say, ladies and gentlemen, is when you take the inverse sine, there's two possible answers. You could have 74.21 degrees, or you could have 105.79 degrees. If you want to check that, take the sine of 105.9 or 79. You're going to get 0.96225. Take the sine of 74.21. You're going to get 0.96225. Why do they same work? Because exactly what I said here. What's the sine of pi over 6? 1/2. What's the sine of 5 pi over 6? 1/2. So they both have the same value, right? Now we're just dealing with some decimals and some angles that are not the same, but now we have 74 degrees. So we're saying the sine of 74 degrees is exactly the same as the sine of 105 degrees. Does that kind of make sense? So we need to make sure we include both solutions. And now we got to see, can both answers work? Can both of those answers work? Yes?
Why would you do the inverse sine when you only give you 74.21?
Because your calculator is just going to give you that positive solution. It's not going to work with the reference angle of the other one. Okay? Because it's not going to give you both solutions. It's just going to give you that one positive, smallest solution. Well, what it's doing is just giving you really the reference angle solution for there. So now we have two possible solutions. Yes?
So the pi over 6 and 5 pi over 6 were just an example. They don't have anything to do with the problem.
No, I was just trying to showing you why when sines equal to each
So I
other.
was like, well, where did you get that?
Okay, so now let's just make sure that these two problems work. So let's do case number 1. So if I said case number 1, I'm saying A equals 60, and then I could say C equals 74.21. So therefore, what does B have to equal? Well, it equals what? Well, let's just do 180 minus 74.21 minus 60, and equals 45. You said one?
No, I thought, when is B that at 105.79?
Well, no, B equals 45.79. That's case number 1. If we did case number 2, what we're saying for case number 2, A still equals 60 degrees. But now I'm saying C, rather, because remember, C could be 74 or it could be 105. It could be either one. So let's say, what if C equals 105.79 degrees? Then what would B equal? Well, let's see if this will work. So I could do 180 minus 105.79 degrees minus 60. Therefore, in this case, C is going to equal 14.21. These are all degrees. Okay? So first of all, the thing you guys need to understand is we can have multiple answers for C. Right? Because our signs is exactly the same. Then, what I do is I just subtracted these from 180. So if C is 74.21, that means B is 45.79. If C is 105.79, that means C is 14.21 degrees. All right? So let's go back and let's take a look. See, for this triangle, does that kind of make sense? Well, if this is 60 degrees, and then I could say C is going to be 74.21, and then B is 45 degrees. All right, so I didn't draw my triangle perfect, but you guys kind of have an idea. It kind of looks similar, right? Let's go and take a look at, so that's case number 1. Let's go and take a look at case number 2. What would a triangle look like what would my triangle look like if I still had A was 60 degrees, but now my C is 14, but now, or my B. But now B is 14.5, and C is going to be 105 degrees. So let's pretend it's going to be something bigger, like 105 degrees. So now it's 105 degrees, and we'll call C kind of something like that.
Why are you changing?
Here, I mean, all you need to understand is this could be here. Let's say that's 60, right? Then it could look something like that. Okay, so this is 105 degrees, and then this is 14.21. So you have C, A, and B. Do you guys see how these are exactly the same triangles? But now rather than having C be 74.21, now it's a obtuse angle, so it's going to be greater than 90, so it's going to be like 105 degrees. So therefore, your B is obviously has to be smaller. But you guys see how there's two, I know like my triangles aren't like just shape or form, but you guys can see how there's two possible solutions. There's two cases. So this is case number 2. In case number 2, we're saying A equals 60 degrees, C equals 105.79, and B equals 14.21. So when we have two cases, there's two possible solutions. What we need to do is now find the rest of the information for both of them. So when we look at this one, we already know what A is, but we don't know what B or what C are. So we need to use the law of sines again. So I can just use A over sine of 60 degrees equals, we're going to have, sorry, that's 9. Sorry, 9 over sine of 60 is going to equal B over, yes? The remaining angles. We don't know what B is, but we know what 10 is. Or we know C equals 10, right?
Yeah, why can't
We can't use the Pythagorean theorem unless you have a right triangle, right? So that's why you have to go back to using the law of sines. Yes?
So are we trying to find the last angle for both of them? Both triangles?
No, we found, when we found C, we found there's two possible answers for C. It could be 74.21 or it could be 105. There's two possible answers for it. All right? So then if there's two possible answers, that means your third angle is also going to be different. Okay? Yeah. Because look at, you can see I can draw a triangle with A being 60, A being 9, B being or C being 10, but them with having the same angles and the same sides, but just one being an obtuse angle and then one being an acute. Okay, so it's possible for me to draw a triangle with an acute and an obtuse, but with the same information upper given. That's what I said. When you guys have a side-side angle, there's three options. I showed you when there's no triangle that can be formed. We did last class period, we worked on ones where there's only one triangle formed. And today we're seeing when there's two triangles can be formed. All right? So now the only last remaining information I don't know is what B is. So I just go and solve for B. So B equals 9 times sine of 45.7 divided by the sine of 60 degrees. And then here I need to figure out what B is. So I could use either the same ratio or I could use a different ratio. Let's just use a ratio for C. So I could do 10 over the sine of 105 degrees equals B over the sine of 14.21. Notice how sine of B is different for each one of these. So therefore, in this case, B equals 10 times sine of 14.21 divided by the sine of 105 degrees. So let's go and figure out what each value of B is. Because for each triangle, B is going to be different. So I have 45.7 sine times 9 divided by 60 sine. And I get, in this case, B is equal to 7.44. Okay? So for in this triangle, in case number 1, I say 7.44. And let's look at it. Does that kind of make sense? Well, at 60 degrees, my side length is 9. Right? At 74 degrees, my side length is 10. So if my angle B is smaller than all those other two angles, then length B should be smaller then, right? Does that kind of make a little sense? Okay. So now, if I give an angle of 14.21, do you think my new B is going to be larger or smaller than 7.44? Should be smaller. So let's go and take a look, see if we did the math correctly. So I do 14.21 sine of that times 10 divided by 105 sine, and I get B equals 2.541. And there you go. There's two possible answers. We notice here is whenever you guys are given the information, before you even try doing anything, let's go ahead and sketch a picture, right? And we can all do this no matter what we're doing because you're going to be given information, and what we have to do is try to identify. So let's just sketch a triangle. Now, again, we can assume that this is an acute oblique triangle, meaning all acute angles. But we know there could be an issue here is 68, that's going to be 18, A would be 19. Okay? But we know that when we have the case of our ambiguous case, we could have an issue with that being, we could have an issue with this being it could be an obtuse triangle as well, right? And we'll look at that when that comes up. However, based on this information, we see that we have angle side side. So it is the ambiguous case, meaning we could have information that doesn't even create a triangle. We could have just this one triangle that I drew up there, or we could have two possible triangles. And again, I'll go over that again as we get to it. But the first thing is we could all just solve for A, right? We can just at least solve for A. OK. So again, to solve for A, we're going to want to use the law of sines, and we're going to want to make sure A is in the numerator. So I'll say sine of A over A is equal to, we have the ratio of C, so that'd be the sine of 68 degrees all over 18. And again, we've already worked on this last class period, so I'm just going to write this next one to solve for A. Oops, I'm sorry, we know what A is, which is 19. So therefore, A equals sine inverse of A equals sine inverse of 19 times the sine of 68 degrees all over 18. Now, do you guys need me to show you again how to do that on the calculator, or can I just type it in and figure the answer and you guys can verify with me? Is that how it works? OK. So let's go ahead and type that into our calculator. You can type it all at one time. Just be careful when you guys are typing stuff in. Make sure you're using your parentheses. So make sure your calculator is already in degree mode. So I have sine, and if you guys didn't already get calculators, you guys can grab them on the back if you want to verify your stuff with me instead of walking right in front of the video camera, but that's OK. So we have sine of 68 divided by 18 times 19. And then we do sine inverse. And I am getting A equals 78.15. Let's round this to the nearest thousandth. Now, the next thing we'll want to go ahead and do is we're going to want to store this answer. OK, we're not going to want to use, we can use this as our final, we can use this angle as our answer. But we want to make sure we store A. So I'm going to go and get store. And then I'm going to, stow. And then I'm going to hit alpha A. And again, when I go over the next problem, I can show you guys this again. But we'll go ahead and store alpha A. OK. Now, do you guys want to finish solving this and then check for the second triangle? Or, yeah, let's go and finish this. Let's just go and finish this. The next one, we've got to find B. So to find angle B, we know that all the angles in a triangle add up to 180. So to find angle B, all I'm going to do is say 180 degrees minus my stored angle A minus 68. So that's why we like storing it, because we don't have to retype the problem again. So do 180 minus alpha A minus 68 degrees. And I get here 33.848. That means I stored it in my calculator.
Like this. So you don't have to. Yeah, there's more on that if you want to grab one.
So I'm going to store that answer as angle B as well. So that's going to be 33.848. OK? Yes, no, maybe so? Yeah. Good? OK. Now, the next thing, though, guys, is we need to solve for little b, right? So if we're going to finish this, we got to go ahead and solve for little b. So therefore, I can use a law of sines again. And now I'm going to solve for b, but I'm going to want to make sure b is in the denominator. And when I'm solving on this example, when I'm solving in this case, we're going to want to have b in the numerator, because that's what I'm solving for, over sine of b, which is stored in my calculator, equals, now again, we could use a over a or c over c, but since c was given to us, c and big C was given to us, that's what I'm going to use. Now, go ahead and solve in for b. b equals the sine of stored b times 18 over the sine of 68 degrees. So we go ahead and type that into our calculator. Sine of stored b times 18 divided by the sine of 68. And I get 6.657. We'll round that. All right. Now, it's important that once we do this, we want to check using kind of the hinge theorem of geometry to make sure that does the smallest angle have the smallest side, and does the largest angle have the largest side? Does this kind of work? Yes, it does work, right? OK, so now we've kind of solved for this one. But what if my question was saying, hey, is there 1, 2, or no triangles? Right? Is there another triangle that works? We know that it makes a triangle because we're able to confirm it. If we did this first sine inverse and we got an error, then we know the problem, there would be no triangle exists. Like the information provided does not create a triangle. That happens when you guys have that error off the bat. But in this case, we know one triangle exists. What about a second triangle? So again, we got to understand, guys, what is happening with sine inverse. When we're doing sine inverse, our calculator, so we're doing the sine inverse of, or here's our angle A is 78 degrees. 78 degrees is right here. Let's just round it to 78 degrees. OK? Now, if we were to think about that like on the unit circle, is there another angle where you take the sine of that angle, you're going to have the same y coordinate?
Wait, where'd you get 78 degrees from?
That's the angle that we found, A.
Okay.
Right? And I'm just rounding it for ease of use. Wouldn't you guys agree that these two angles have the same y coordinate? Or at least they're supposed to if I drew them correctly? Yes. Right? Now, so that means, now what exactly is this angle, though? Like, that's the reference angle. So what is this angle?
It'll be the 180 and then do it by.
Huh? What is that angle? What is that measure of that angle? 102, right? Because 78 and this angle, 102, are supplementary. So all if I got to do, now again, we'll come back to this in a second. Would you guys agree that the sine of 78 degrees is equal to the sine of 102 degrees? Would you say that their y coordinate is exactly the same?
Yes.
Yes, right? Yes.
For B, I keep getting 10
A little bit.
Yeah.
That's what I got too.
Oh. Well, why don't you guys say something? So maybe let's make sure I didn't store my b. Oops, no wonder. So 180. Let me make sure my alpha a is correct. Sorry about that. I didn't store big B.
Big Brandon.
Sine of alpha b. What'd you get? What is your b? B is 33.84, right? OK, and then sine of b. So the sine of alpha b times 18. Did you guys divide it by sine of 68? OK, there we go. I don't know what I typed in wrong. Thank you. Oh, good catch. So that's 10.813. OK. Now, let's go back to the second case. You guys agree that the sine of 78 degrees and sine of 102 is the same, right? Now, here's the problem. When you guys do sine inverse, which we did over here, when you do sine inverse, your graphing calculator is only going to give you sine 78 degrees. It's not going to give you 102 degrees, even though the sine of those two angles is the same. Why does it only give you that one angle? Because again, remember the inverse function is restricted. It's only going to give you that angle in the first quadrant or the fourth quadrant, right? It only gives you that positive or the negative right here. It's not going to give you the obtuse angle. However, is it possible that our triangle that we create could have an angle of 78 degrees, or it could also have an angle of 102? Is it just possible? Yeah, those are both angles that could be a possibility. So what we need to do is, since the acute or the obtuse angle have the same sign, sine inverse only gives you the acute. So we have to check the obtuse. So what we're going to do is we're going to call this A2. So it's really A2 of our second case. So I'm just going to call this my case number 2. So we solved case number 1. Now we're going to work on case number 2. So what we mean by case number 2 is we have the exact same triangle. This is still 68 degrees. This is still 19. This is still 18. But A, we're going to say, is now obtuse. Because couldn't A be obtuse as well as be acute? It could, and let's see what it is. So now, rather than estimating, we don't want to do that. We want to take 180 degrees minus A that we stored. And we're going to store that as, or we're going to figure out that value. So now I'm going to do 180 minus alpha A. And I get 101.848. So could this be a possibility? Could that angle be 101.848 and then have 68 degrees? Yes, it works, right? Now, so that means this example has two triangles. However, let's just pretend, what if this angle ended up being like 150 degrees? Is it possible to have 150 plus 68? No, so therefore only one triangle would exist. So even though you could test the obtuse angle, it wouldn't create another triangle. But in this example, two triangles can be created. All right? So I am going to store this as my new A. So I'm just going to take this new answer, and I'm going to store that as my new A. So store alpha A. OK, so now alpha A is 101.8484628. Don't want to use the rounded answer. Make sure you use the whole answer. So now I need to figure out a new B, right? So we're going to say B2. So what would B2 be? Well, B2 is 180 degrees minus my new stored A minus 68 degrees. Right? You guys agree with me on that, hopefully? So we do 180 minus stored A minus 68. And I'm getting 10.152 if I round it. And I'm going to call that my new stored B. So now I'm going to store that as alpha B. Are you guys OK with the storing and everything? Do you guys want me to go back over that next problem? Yeah?
Sure.
OK. So now we have A, and we found B. So the only thing I need to check is small b. Now again, since we're solving for small b, we're going to put small b in the numerator here. So I'll have b over the sine of stored b equals, let's again use c, which is 18, over the sine of 68 degrees. So therefore, b equals the sine of my new stored b times 18 over the sine of 68 degrees. So it's really the same thing I did way over here. It's just with new b's, though, right? So I do sine of alpha b times 18 divided by the sine of 68. And I am getting b equals 3.42. And does it make sense, guys, for B to be kind of small in this example? Right? Because look how small that angle had to be. Right? So a really small angle is going to produce a really small side. Right? Which is different than this one. But this one made sense. And so does this triangle make sense? Yes? No? Maybe so? OK. And there you go.